In topic 2 of module 3, we're going on to concept reinforcement, in which we have some statements and we want to determine whether they are true or false. Let's see if I can get it just where I want to get it here. I don't want to cut out anything. There we go. So we'll pause it, we'll give assignments, and again we also want why if it's false. Why is it false? Let's pause. Okay, we'll go over what you did, and this is a very good review. A common denominator is required in order to add or subtract rational expressions. That's true. To find the least common denominator, we find the least common multiple of the denominators. That is true. Number 3, it is rarely necessary to factor. Well, rarely is what makes this wrong. If it were replaced with often necessary, that would be true. In this form, it's false. The sum of two rational expressions is the sum of the numerators, that part is true, over the denominators, that is the common denominator, not the sum. That's what makes this false. The least common multiple of two expressions is always the product of those two expressions. That is not true. To make it true, you would say a common multiple can be found by just multiplying, but it not necessarily is the least. So, again, multiplying the two denominators gives you a common multiple, but not necessarily the least common multiple. To add two rational expressions, it's often necessary to multiply at least one of those expressions by the form of 1. And here we say 1 is equal to 2 over 2, 4 over 4, x plus 1 over x plus 1. These are all forms of 1. And we have to find the one that will give us our common denominator. And this one's true. Well, let's go on to 7. I think we skipped that one here. Yes, after two rational expressions are added, it is unnecessary? No. It is often necessary to simplify the results. That's what makes this false. And parentheses are particularly important when we are subtracting. So if you subtract something and they're in a parenthesis, we remove the parenthesis and change all the signs. That's the key to that one. All right, let's just do a few more here. So as we look at these, and again, you'll be practicing, let's just do a little bit of background. Here, our denominator is going to be the same. So we just add our numerators. Now, once we've done this, we now see we can do some canceling. So 3 will go into there once, 3 will go into there 5. So this now becomes 5 over a. We had common denominators, we add our numerators, and we simplified. Now, this is critical. Our common denominator, let's see if I have some room down here, will be 3m squared n squared. And now this is critical. 5. Now I often suggest change this to plus and put the negative over there. So this is going to be 5 minus 4, which will be a 1 then over this common denominator. Now as you look at number 13, the common denominator is there. And notice that this term and this term now are common terms, and so are the x's. We can add those together. So we're going to get here 2x plus 2y over x plus y. And if you left it that way, that would be incorrect, because notice you can factor out a 2 from the top, and this becomes x plus y, and that's going to be over x plus y that I'm putting in a parenthesis, and I can put a 1 there. And now these cancel out, and I'm left for this one as 2. Now here in number 15, it's critical. Our denominator is t minus 4, and we have then 3t plus 2, but I'm going to put this as a plus, put this in parentheses, and put the negative up there. So now this becomes a negative t. Change this sign, plus 2, and I now get 2t as I subtract my common terms, and this is plus 4. Now notice you could factor out a 2 here, but since it's not going to result in anything factoring out, you could leave it this way. Okay, well, there's plenty of practice, and here's where the practice really starts, in examples like these where you have to factor them, find your common denominator, and then modify your numerators so that these are equivalent fractions, and you'll be practicing that.